What was the problem with the Hubble Space Telescope and how was it solved? According to Chapter 6 of our OpenStax text, the problem with the Hubble telescope is that the primary mirror that was used in the telescope had an error in its shape. Our text describes this error as being equal to 1/50th of the width of the human hair. I did external research on an Australian CIO website where former NASA Director of Astrophysics Charlie Pellerin was profiled. Pellerin calculated this distance as 1.33 millimeters. The article quoted him as saying, "Holy Christ, in an optical system, this is like missing by 1,000 miles." This incorrect distance led to a decrease in image quality. All the images obtained by the Hubble telescope were blurry. Pellerin was called in by his boss to discuss the problem of these blurry images upon their discovery. His boss asked him, "What do you know about spherical aberration?" Pellerin answered, "I said, all I know is when amateurs build mirrors and do it sloppily, they get what's called a downturned edge, and on different radii of the mirror, it focuses the light on different parts of the optical axis, and it's physically impossible to ever focus a telescope. They're useless." The technical term for the phenomena Pellerin described is spherical aberration. The telescope Hubble had metering rods, and the ends of these rods were rounded and polished. A beam of light on the end of the rod would then be focused into the center, which would provide the correct measurement to center the metering rod with respect to the infometer axis. A field cap was attached to the end of the rods. Field caps are known as dust caps and are intended to keep dust out of a telescope. The instructions for the field cap were for it to be spray painted black. However, Pellerin says, "The guy was working under great stress because we were angry about costly delays and we were threatening to put Kodak's mirror in the telescope, which would have been humiliating for our contractor Perkin-Elmer. So he's working, he's really hurrying, and he can't find the spray paint. So instead, he puts black tape on the cap and he takes his X-Acto knife and cuts a hole. He doesn't notice he made a shiny little burr. So he puts the thing on, the light hits the burr and goes back up. His instructions were to move the thing in every direction to see if the intensity of the light went down. So he moves it. Light goes onto the black tape, onto the black tape, onto the black tape, down to the hole in the field cap. He assumes he got it centered. However, the light hit the burr instead of the top of the rod, which led to a gross misplacing of the two mirrors." With all of the smart minds working together on this project at NASA, how did this occur? One of the reasons this happened, according to Pellerin, is that the project ran over budget. The original budget for the Hubble Space Telescope was $434 million, and by the end of the project, the cost was over $1.8 billion. In addition, NASA had created what Pellerin describes as a hostile environment for Perkin-Elmer, their contractor, in which they told us about any problem at their peril. He attributes the issues with the telescope not to the individual contributors to the project, but to the team culture where they took for granted that the mirror was perfect. So everyone assumed the mirror was centered, and when there was a problem, it was because of the force of gravity in the telescope mount, rather than the problem being that the lens was not centered correctly. Pellerin believes this cultural problem was due to a tight deadline and a culture where higher-up leaders did not want to hear anything about problems, only solutions. How did NASA solve this problem? Our text explains that the solution is similar to what we do for people with blurry eyes. The same way corrective optics or glasses can correct blurry vision, corrective optics were installed on the telescope. Pellerin realized he could fix the problems of the Hubble telescope because the optics were flawed, but not irregularly so. He used a $2 billion budget he was allocated for other projects in NASA and took $60 million of that to start a servicing mission for the Hubble telescope. He sent the servicing team to remove an unimportant instrument from the telescope called a high-speed photometer. Once this was removed, they inserted another mirror in the Hubble telescope, which was deformed proportionally to the flawed telescope lens. The mirror was called COSTAR, which stands for Corrective Optics Space Telescope Replacement. This corrected the error by the time it hit the other telescope instrument. The other telescope instruments were called Faint Object Camera, Faint Object Spectrograph, and the Goddard High Resolution Spectrograph. Like our text, Space and Telescope says that the COSTAR acted like a giant pair of spectacles, refocusing the light and letting instruments see clearly again.